Okay, so first off, I miss you guys, and I hope that we're back to school soon. But in the meantime, we're going to work through our Making Models packet. So to do this in class, this would have taken many days and would have served as our big lab where we would have then built these molecules. So for today, you're going to do only the number of valence electrons, the names, and the dot structures. We will work on the shapes, redrawing, and polar and nonpolar next week. So to do this, when we've been working on naming, we've only been naming binary molecules. Binary means 2. So for any of the ones that are more than 2 elements, we are not going to name those. So I'm going to go through and cross off for today this one and this one, because those have carbon, hydrogen, and chlorine, and then carbon, hydrogen, and oxygen. So you don't need to name any of the ones that are not binary. Remember, for naming, you're using prefixes, never mono on the first one. So for example, HF would be hydrogen monofluoride. So we never use mono on the first one. We do use it on the second one, and the second element always gets that IDE ending. So when you're counting your valence electrons, you want to look at each element and know how many valence electrons it has. You need to look at your subscripts to see how many you have of each atom. You multiply by the subscripts, and then you add them all together. So when we're looking at CH2Cl3, carbon has 4 valence electrons, and I only have 1 carbon, so it's contributing 4. Hydrogen has 2 valence electrons. Hydrogen has 1 valence electron, and I have 2 of them. So hydrogen is contributing 2 valence electrons. Chlorine has 7 valence electrons, and I have 2, so it's contributing 14. That means all together for my valence electrons, this compound has 20. So 14 and 4 is 18, and 2 gives me a total of 20 valence electrons. So then, since we're not going to name this molecule, we're going to follow our directions from our previous notes and draw our dot structures. So the very first thing that I did is total number of valence electrons. I have 20. Second, I need to locate my central atom. It's always the atom that needs more electrons to make an octet. So I have carbon, I have hydrogen, and chlorine. The rule is it's never hydrogen. Hydrogen is never going to be in the middle. So chlorine has 7, it needs 1 more. Carbon has 4 valence electrons, it needs 4. That means carbon goes in the middle. So carbon almost always is going to be your central atom. I then need to place around it the other elements. So I have 2 hydrogens. It doesn't matter where you put them. And I have 2 chlorines. My next step is to fill in their valence electrons. So with my other atoms around it, carbon has 1, 2, 3, 4 valence electrons. Each hydrogen has 1. So in between carbon and hydrogen, I have a single bond between each of them. Chlorines have 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. And this chlorine has 1, 2, 3, 4, 5, 6, 7. So in between carbon and this chlorine, I have single bonds. So if I were to look at my structure up here, carbon is single bonded to the hydrogens and single bonded to these chlorines. So each one has 1 single bond. I don't have any electrons that are not bonded. That's as far as we're going today. So you should complete page 1, so just these elements from CH2, Cl2, down to SiO2, filling in valence electrons, names, dot structure. Tomorrow, you're going to do page 2, and then on Friday, you'll do page 3. On Friday, you're going to submit this so far. So your built column, your shape, your redrawing, your polar, nonpolar is staying blank. On Friday, your submission should be pages 1, 2, and 3, completed for counting your valence electrons, naming, and dot structure. We'll get to the rest of it next week.